Hi there, this is a geometry video. It's chapter 6, section 4, and today we are going to be discussing rectangles. In our previous section we talked about different types of parallelograms, and a rectangle is definitely a type of parallelogram, and there are a couple of things that we know about rectangles in particular that are not necessarily true of all parallelograms, but are definitely true of rectangles. One of those is that all four angles are right angles in the case of a rectangle. So there's some properties in the blue that we already know about rectangles. And then this last one is one of the things that sets them apart as well. So we know that for all parallelograms, opposite sides are parallel and opposite sides are congruent. We know that opposite angles are congruent. We know that consecutive angles are supplementary. So basically angle A and D add 180, D and C add 180, and so on and so forth. And of course, we also learned in our previous lesson that diagonals bisect each other in the case of a parallelogram. But even more so, what happens with a rectangle is that the diagonals not only bisect each other, but the diagonals are congruent. And that isn't necessarily true of all parallelograms. So that's unique to our rectangles. Well, it's not unique to the rectangle. There's another figure that has the same thing, but it's not all parallelograms. So rectangles for sure, diagonals are congruent. So that would mean that the segment from A to C would be congruent to the segment from B to D. And so we're going to do or look at some examples here. And our first example is actually, it has a whole storyline that goes with it, but in the interest of space, I didn't write it all down. But basically, in your book, it's a rectangular park, and it has two walking paths. So these are your walking paths here. And it says that if PS is 180 meters and PR is 200 meters, they want us to find QT. So PS is the side of the triangle here, 180. And PR, which is a diagonal, is 200. And they want us to find QT. So the thing is that if PR is 200, the way that we're going to solve this little guy is using our properties. If PR equals 200, it means that QS also equals 200 because diagonals of a rectangle are congruent. And also we know that the diagonals bisect each other here at point T, which means that this point cuts the diagonal into two equal parts, and those equal parts are the same in all four directions there. So basically we can then take this and divide it by 2, and then QT will equal 100 meters. So that is how we get the length of QT for this example. Now an example, in do-it-yourself 1, A and B, we want you to still use the same figure from example 1, but with different information. So you can do that, and then we will move on to another example. So in example 2, it says quadrilateral JKLM is a rectangle, and if the measurement of KJL, so here's KJL, so this angle right here is 2x plus 4, and the measurement of angle JLK, which is JLK over here, is 7x plus 5, find x. So basically what they've given us is this angle here and this angle there, angle 1 and angle 2. So angle KJL is angle 1, labeled angle 1, and JLK is labeled angle 2 right now. And what we also know is that because it's a rectangle, all four of the corners have to be 90. So as we look at triangle JKL, we know that 90 plus angle 1, which is 2x plus 4, plus angle 2, which is 7x plus 5, should all add up to 180. Also, if you didn't want to do that, if you already knew this one was 90, you could have just taken these two angles and had them equal to 90, which is what we're going to end up doing anyway, because we're going to subtract this 90 from both sides, and we will see that we get 180 minus 90 on the right is going to equal 90. And then over here we're going to get our 2x, and 7x is 9x. and then 4 and 5 is 9. So that's what we end up with. So we subtract 9 from both sides, and we get that 9x equals 81. Divide by 9, and x equals 9. And that's what they asked us to find. They asked us to solve or find x. So now again, we want you to use the same figure, and this time use this information to find y, and then we will go on to our converse. Now I'm not going to write the converse on the board, but the theorem that we had for this lesson is that if a parallelogram is a rectangle, then its diagonals are congruent. And we saw that basically, I didn't write it in an if-then format, but that's basically what this little guy right here is saying in the original slide or whatever that we had. This theorem right here is that if a parallelogram is a rectangle, then the diagonals are congruent. So now, the converse of that would be that if the diagonals of a quadrilateral are congruent, then we know that it's a rectangle. So in example 3 it says if AB equals 60, so I'm going to label that, BC equals 30, CD equals 60, AD equals 30, AC, which is a diagonal, equals 67, and BD, the other diagonal, also equals 67. Explain how we can be sure that the quadrilateral is rectangular. And we can be sure because we can see that the diagonals bisect each other and the opposite sides are congruent. Therefore, we know that it's a rectangle. So basically, we're applying the converse here. They want us to know, like, we know that if diagonals congruent, then rectangle. And in this case, we've just identified that the diagonals, which are BD 67, AC 67, are congruent. So therefore, this is a rectangle. And so now, in a similar fashion, we have a diagram, and it's got two of the sides labeled. This is a 36, not a 3B. We know that this is a 90-degree angle. We don't necessarily know that these are 90-degree angles, but we know this is a 90-degree angle. And these two sides are 80, and this is 36. And it's asking, can you conclude with the information in this diagram that the figure is a rectangle? And if you can, explain. So that's going to be left for you to do. And then we're going to go to our last example. Not a very long lesson today. And that is another coordinate geometry going on here. So quadrilateral PQRS has vertices P, -5, 3. So the first thing we're going to do is go ahead and graph, plot the points here and graph our quadrilateral. -5, 3, so 1, 2, 3, 4, 5. -5 on the x-axis, +3 on the y. It's going to be right about there. That's point P. Then Q is 1, -1, so that's going to be right here. X is 1, Y is -1, that's Q. Then we have -1, -4, so here's -1, -4, and that is R. And then S is -7, 0, and that's going to be way over here, and that's S. And then we're going to connect our points. And they want us to determine whether PQRS is a rectangle or not. And they want us to do this by using the method of the distance formula. Now there are other ways to be able to prove this. You can use the slope formula to confirm that, that all the sides, opposite sides are parallel. And also that all of the angles are 90 degrees, that there's 4 90-degree angles. You can do that with the slope formula. You can also confirm with the distance formula that the diagonals are congruent. And so that's what we're going to do right now. So we're going to take the diagonals. It's important for you to draw the diagram because you need to know which points are the actual diagonals. So for example, if you're only looking at the vertices, you might go, oh, PQ is a diagonal. But if you look at the diagram, PQ is a side, it's not a diagonal. So our two diagonals are PR and P is negative 5, 3, and R is negative 1, negative 4. And then, so P to R is one diagonal, and then we have S to Q is our second diagonal. So S was negative 7, 0, and Q is 1, negative 1. All right? So now, we are going to do the distance formula to find PR. The distance formula, if you remember, is going to be the difference in the x values squared and the difference in the y values squared. So I'm going to go negative 1 minus negative 5 squared, and then I'm going to go negative 4 minus 3 squared. So my difference, my difference between negative 1 and negative 5, and between negative 4 and 3. So that's going to be negative 1 minus negative 5 is negative 1 plus 5, which is 4, and then we square that. Over here we get negative 4 minus 3, which is negative 7, and square that. So 4 squared is 16, negative 7 times negative 7 is 49, and so then we get 16 plus 49, and 16 plus 49 is going to give you 65. So we have the square root of 65 as the distance of our first diagonal. So now we're going to try to find the distance of our second diagonal, and hopefully it'll be the same. And if it is, then we can determine that this is a rectangle. So again, this time we're doing the same thing, difference in the x values. So 1 minus negative 7 squared. Difference in the y values, negative 1 minus 0 squared. And so we get here that 1 minus negative is 1 plus. So 1 plus 7 is going to give us 8 squared. Negative 1 minus 0 is just negative 1, and we're going to square that as well. And 8 squared is 64, and negative 1 squared is positive 1. And again, we get 64 plus 1, which is, lo and behold, the square root of 65. And since both of them have the same length, then our diagonals are congruent. And because our diagonals are congruent, this, in fact, is a rectangle. So now we're going to ask you to do this example where you want to find the slope of all 4 sides, and you want to compare that the opposite sides are parallel, but you also want to compare that adjacent sides that are forming 90-degree angles. There should be 4 90-degree angles there. And so once you have completed this example, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.